Welcome to the very first lab. In this lab, you will learn basic tools and concepts required for the information security lab. In particular, you will learn these essential skills by detonating the bomb lab. The learning objective of this week's labs are in two folds. First is to identify the basic concepts of x86 32-bit architecture and assembly. Second is to recognize necessary tools required for later labs and the workflow of getting and submitting flag. In this week's tutorial, you will learn the detail of x86 architecture and assembly.
So how's your bomb lab going?
I don't know how to run the bomb lab.
Well, first you got to register on the website and get your API key.
Okay.
So point one, so to run the bomb, you need to register on the website first and get the API key.
So my bomb just exploded.
Well, you shouldn't just guess the answer. Before you type, make sure you really understand how each bomb lab works.
Okay.
Let me explain to you how it works. When you run the bomb binary, it simply asks you a question. Your job is to find the correct answer. It consists of 10 phases, so you should find 10 answers, and perhaps more. Whenever you successfully pass the phase, you'll get the flag. Otherwise, your bomb will just explode. Point two, be careful when you're handling bombs.
Okay, so I just got my first flag. What do I do next?
Great, easy. Point three, once you get the flag, make sure you go to the submission website and submit the flag under the corresponding problem set.
But why is my flag not correct?
Well, that's because you didn't run the official copy of the bomb program. You can think of the flags generated by copied programs as test flags. In order to generate the correct flag, you'll need to run the bomb program that's sitting in the Lab 1 home directory.
So is that a test explosion?
Sorry, anytime you run the bomb program with your API key, the explosions are real because the explosions are reported back to the scoring server. Point four, when you're generating a flag for turn-in, make sure you run the binary out of the Lab 1 home directory.
Okay, that worked.
To access the tutorial, you first have to log into the lab server hosting the first lab challenges. So please find the exact information in separate materials. Once you log into the server, you can find README files under the tutorial correct me directory, which describe the detail of each step that you should follow. Let me first demonstrate the GDB commands. To initiate the debugging, you can simply type GDB and the target program name. In this case, I provide a crank me challenge that you will see in the tutorial. First, we will place a breakpoint at main, meaning that the program will stop when it hits the breakpoint. To run the program, simply type run. Now it stops at the entry of the main function. At this point, we first like to check the current registers by typing info R. Then let's check current instructions by typing X as examine and 10I as a format specifier with the code address. In fact, instead of typing the address, you can also refer the value of register by using a $sign. To know the detail of each command, you can always type help with the command name as an argument. To execute the following instruction, you can type step I, or shortly SI. Let's check the current instructions again. To show the current instruction whenever GDB is stopped, you can use the display command. After that, it simply print out the current instructions whenever GDB is stopped. At this point, we are about to execute the call instruction. If you type SI, you simply follow the call instruction. In this case, the put function in the libc. Since we are not interested in the put function, let's continue to execute until it returns by typing finish. Let's continue to execute until we see another call instruction. You can simply type enter to repeat the last command. At this point, we like to stop at the next instruction instead of following the call instruction. So type next I, or shortly NI, to proceed to the next instruction. Let's continue to execute by typing C. You can see the program is waiting for your input. You can interrupt the program by typing Ctrl+C, which is send a signal to the target program. To check the frame information, just type backtrace or shortly BT. You can see the code chain from the main function all the way down to the system call. Let's see the breakpoint at the next instruction of scanf so that you can check the logic after we provide some input. I continue executing the program and provided an arbitrary input, simply AAAA. It stopped, as you expected, right after the scanf call. To print out the buffer, just type pbuff. It will simply print out what's inside the buff. Or you can examine the memory as before by running the examine command as we discussed before. To terminate the GDB session, simply type quit. In summary, this week's lab provides you the basic concepts and tools required for later labs. In particular, you will set up the working environment and learn GDB command and game rules by detonating bombs in the bomb lab. Happy hacking!